Hello everyone. Good afternoon guys. How are you? Hi Shillong. Can you hear me? Am I audible and visible to you? Okay, so what's up guys? How are you? Mark your attendance please. Oh, hi Itanagar. Okay. So guys, can you please share the topic that we were discussing in the previous class? A topic that was under discussion in the last class. So that we can proceed. I think I have given you a few questions as well, if I'm not wrong. I have given you some homework as well. Please tell me. Yeah, I have given you questions based on the ionization enthalpy. I just got that. I have given you questions based on the ionization enthalpies. Guys, have you attempted all those questions? If not, then I'm giving you 2 minutes to attempt all those questions, then we will start. See, these are the questions. We have to compare the ionization enthalpies. First one was boron versus beryllium, then chromium versus manganese, then copper versus nickel. Number 4, chromium versus Cr plus. Number 5, Cu versus Cu plus. Number 6. Cu plus versus Cu2 plus. Guys, answer these questions. Those who have already done these questions at your home, answer these questions. This is the compare the ionization enthalpies. Question was compare ionization enthalpies. I'm giving you 2 minutes. You can start. Guys, after attempting the question, please reply on the screen. Done? Guys, are you done with these questions? Even after giving you the homework, you haven't completed that, and still I'm giving you some time. So please finish it in the given time. If you need some more time, you can ask me. If you don't want more time, you can reply on the screen so that we can start. Itanagar, have you done this? Shillong? Okay. Itanagar, are you there? Okay. Okay. These are the answers. These are the answers. Look at the answers and ask me if you have got any confusion or doubt regarding this one. If you have got any confusion or doubt, you can ask me. Guys, do you have doubt in any question? Shillong, as answer given by you, that Cr should have the higher ionization enthalpy as compared to Cr plus. Guys, I'm repeating last time. If anyone has got any confusion or doubt, you can ask me. If not, I'll move on to the next topic. I'll talk to the manager regarding this. Itanagar. Okay, I'm moving to the next question. Next topic. Next is electron gain enthalpy. You will represent this in this manner. Delta Eg. Eg stands for the electron gain. Now, let's say suppose A is an isolated gaseous atom. It takes up an extra electron to form A minus, which is an anion. Okay. So during this process, whatever energy changes would take place will be termed as the electron gain enthalpy. What I'm saying? During this process, when an isolated gaseous atom takes up extra electron to form an anion, during this process, whatever energy changes are there will be known as what? Electron gain enthalpy. Okay? So, if I write about its definition, it will be the energy changes when an isolated gaseous atom takes up extra electron to form an anion is known as electron gain enthalpy. Electron gain enthalpy. Okay. Copy this. After copying that, confirm me once so that we can discuss a little bit more regarding this one. Okay. Shillong, have you copied that? Shillong, have you copied that? Oh, hi Kohima. Okay. Now guys, look at this point. The energy changes. Or you can also say this is the, you can also say change in enthalpy. Change in enthalpy. Guys, you can write down this one as well. Or change in enthalpy. You can write down this one as well. So here, we are writing it is the energy changes or the change in enthalpy when an isolated gaseous atom takes up extra electron to form an anion is known as the electron gain enthalpy. Now guys, let's understand it. See, first of all you have to remember that whenever an isolated gaseous atom takes up extra electron, energy will always be released. Please do not copy this, okay? Energy will be released in majority of the cases, okay? It is an exothermic process. Now, I'm taking some example. I say oxygen, atomic number 8, fluorine, atomic number 9. Okay? See, I said both takes one electron, it will form O minus and it will form F minus. I said minus X kilojoule per mole of energy has been released during this process, and here minus Y kilojoule per mole. Okay? Guys, first of all, just look at the screen, okay? Try to understand it. My question is, we have to compare the value of X and Y, means in which process or in which case maximum energy will be released. Okay, I'm asking that in which case maximum energy will be released. So, we have to compare this one. Now, let's start with the oxygen. See, atomic number is 8, so its configuration will be what? 1s2, 2s2, 2p4. This is your 1s2, 2s2, 2p5. Now, the point is, when it will add an extra electron, so its configuration will become 1s2, 2s2, 2p5. Whereas, in this case, it will become 1s2, 2s2, 2p6. Guys, look at both the situation and please tell me, after gaining of electron, which configuration is relatively more stable? The configuration with the fluorine or the configuration with the oxygen? After gaining of electron, which configuration is relatively more stable? Oxygen or fluorine after gaining the electron? You can look at this one. This is your 2p5, this is your 2p6. Which one is relatively more stable? Yeah, exactly, fluorine. Okay. So guys, you have to remember, when extra electron is added to the system, if it becomes more stable, it means that in more stable case, higher energy will be released. Okay. What I'm saying, if after gaining of electron, higher stability is achieved. See, I am comparing oxygen versus fluorine. That after gaining the electron, which one has got the higher stable electronic configuration? So we find out that fluorine has got the relatively more stable configuration. That's why the energy released in case of fluorine would be higher than in case of energy released in case of oxygen. Okay. So we can say that electron gain enthalpy of negative electron gain enthalpy, we can say the negative word, okay, negative electron gain enthalpy of fluorine is higher than oxygen. Guys, first of all, tell me, is it clear to you that why electron gain enthalpy of fluorine is higher than oxygen? Is it clear to you? Is it clear to everyone? Why fluorine will have the higher electron gain enthalpy, higher negative electron gain enthalpy? Shillong, Kohima, Itanagar, guys, is it clear to you? If not, you can reply to me so that I can take another example. Guys, am I audible to you? Okay. Okay, guys, so look at this. Now, one more thing that we have to take a look. Guys, look at this. Oxygen versus fluorine. I'm taking the same example. 8, 9. Okay. The configuration was 2, 5, not 5. The configuration was 2 to 4. So we can say this is your 2, 6. This is your 2, 7. Okay. In the lower classes, we learned that how we can write configurations like this. Okay. So guys, this is for the oxygen and the fluorine. Now, just look at the fluorine and oxygen. If it gain one electron, so it will become 2, 7 and it will become what? 2, 8. Guys, we have to ensure that as much closer we are to the octet means outermost shell should have the 8 electrons over there. Okay. So guys, after gaining the electron, the species which is much more closer to the octet completion will releases higher energy. I'm saying a species which is much more closer to the completion of the octet after gaining the electron will be relatively more stable. Means will relatively releases the more energy. See, fluorine after gaining of electron acquires its octet. Oxygen, in the outermost shell of the oxygen, it has the 7 electrons. If I compare with the nitrogen, okay, nitrogen is atomic number 7. So you can write it 2, 5. After gaining of electron, it will become what? 2, 6. Okay. If I talk about the carbon, which is 6, so you will say it is what? 2, 4. So after gaining the electron, it will become what? 2, 5. Guys, you can see 5, 6, 7 and 8. So here fluorine has achieved its octet after gaining the electron. Oxygen is very much closer now. Nitrogen is again closer but not so much closer as oxygen is. Carbon is again closer but not as much closer as nitrogen is there. Okay. So guys, we can say that on the basis of this particular explanation, in general, on moving left to right in periodic table, electron gain enthalpy becomes more negative. Guys, we have to remember this statement. First of all, make it clear to me that is it clear to you? Do you understand the electron gain enthalpy? that why it will become more negative, or you can simply understand that on moving left to right, nuclear charge increases, so the tendency to pull the electron will be very easy, and if they can pull the electron very easily, they can gain the electron, and those species which can gain the electron very easily will releases the higher energy. This is one more reason for that. Any confusion regarding this one? Guys, is it clear to you? Any doubt or confusion? Shillong, Itanagar, and what's the other center? Show the center once. I'm not getting your question, dear. Shillong, can you write again? Guys, you can copy this one. You can copy this statement. Okay. Is this question for me? Yeah, obviously 2,7 will be relatively more stable. It will have the higher nuclear charge. That is for the fluorine. And 2,6 is for the oxygen, which have relatively lower nuclear charge. So the 2,7 electronic configuration is relatively more stable as compared to the 2,6. Two-7 relatively be more stable as compared to the 2,6. Clear? Now don't be confused that, sir, if after gaining the electron this situation becomes, then you are saying this is 2,7 is more stable than 2,6. I said after gaining of electron you have to just check which species is much more closer for the completion of the octet. After gaining of electron you have to check out that which species will be relatively much more closer to the completion of the octet. You have to check that one. Okay? Now is it clear to everyone? Ultimately, you can think of it, you can simply summarize it, you can say, the species which has a higher nuclear charge will have more negative electron gain enthalpy. You can say, because nuclear charge increases. If nuclear charge increases, then tendency to pull the electron will be very, very high. Okay? This is the first statement. Now the second statement. On the basis of this concept, please tell me what will happen when we will move from top to bottom. What will be effect on the electron gain enthalpy when we will move from top to bottom? Will it become more negative or less negative? More negative means after gaining the electron, it will releases higher energy, and less negative means it will release the less energy. Okay? Please tell me what should be the impact when we move from top to bottom. Guys, are you clear with the question? Shillong, Kohima, Itanagar. My question is, what will be effect or how electron gain enthalpy will vary from top to bottom in the periodic table? Will it become more negative or less negative? Okay. So we can say, in general, on moving top to bottom, electron gain enthalpy becomes less negative. So this is absolutely true. This is absolutely true that in general on moving top to bottom, electron gain enthalpy becomes the less negative. Okay. So my question is, arrange the following. Please do not write it in the fair. You have to just arrange it and roughly, and you have to answer me. Arrange the following in the order of increasing electron gain enthalpy. Means that the element which has the higher electron gain enthalpy should be at the last. Okay. Increasing order of the electron gain enthalpy. Fluorine, chlorine, bromine, and iodine. The species which will releases the least energy will be put at the first position, and the species which will releases the highest energy will be put at the last. Arrange it and tell me the answer. Arrange it and tell me the answer. The question is, you have to arrange the following in the order of increasing electron gain enthalpy. Increasing electron gain enthalpy. Okay. Kohima has got the answer. So guys, let's start. Ideally, answer should be this one. Iodine will release the least energy, then bromine, then chlorine, and the fluorine. Okay. Fluorine should release the highest energy. Reason being, fluorine has the smallest in size and has the highest nuclear charge. Guys, we have discussed that on moving top to bottom, nuclear charge decreases. Okay, so this one should be the order. But guys, this order is not absolutely right, because this is actually the wrong one. This pair is placed wrong. Okay. And this question even asked in your examinations as well, that chlorine has higher electron gain enthalpy than fluorine. Why? This is your question. Chlorine has higher electron gain enthalpy than fluorine. Why? Guys, this is very important question for your examinations. Okay, I have to discuss this one. So now let's take a look. See, first of all, look at this one. This is for the fluorine, this is for the chlorine. Okay, this is just for the understanding. I'll write the whole explanation from over there. First of all, understand this one. Guys, look at this. Fluorine and chlorine belongs to the same family, and their outermost shell contains the 5 electrons. So obviously 5 electrons will also be present over here. Okay. Guys, the point is, in fluorine and chlorine, the difference in nuclear charge is not very high. Okay, the difference in nuclear charge is not very high, means their nuclear charge is relatively very near to each other. Okay, so what is the exact reason that why chlorine has got the highest electron gain enthalpy? See, whenever an extra electron come to add in this orbital, similarly one extra electron will come here to add with this electron. Guys, what will happen? The electrons which are already present in the orbital will repel it. So obviously these electrons will also repel it. Okay. Now the point is, in case of fluorine, the 5 electrons are present in relatively smaller shell, whereas in case of chlorine, the 5 electrons are present in relatively bigger shell. So due to which the net repulsive force felt by the incoming electron due to presence of inner electrons in chlorine is relatively lower as we compared in case of fluorine. Okay, that's why chlorine has got the higher electron gain enthalpy as we compared with the fluorine. Okay, I'm repeating it. Please listen to me very carefully. In case of chlorine, the incoming electron will suffer less force of repulsion due to the inner electrons because they are present in a relatively bigger shell. If they are present in the relatively bigger shell, the force of repulsion will be less, and if force of repulsion is less, it means gaining of electron relatively easy. Similarly, in case of fluorine, if I talk about fluorine, electron will also suffer the force of repulsion due to presence of inner electrons, but here the repulsive force will be very high because the size of the shell is very small, due to which the force of repulsion becomes very large. That's why the incoming electron suffers much more repulsion and it is difficult to gain. That's why in case of fluorine, electron gain enthalpy becomes less as compared to the chlorine. This is the exact reason. First of all, please tell me, is this clear to everybody? I'll write this whole explanation to you. First of all, tell me, is this explanation clear to you why chlorine has got the higher negative electron gain enthalpy than the fluorine? Because this question is very important with respect to school examinations. Guys, is it clear to you? Anyone has got any confusion or doubt regarding this one? Okay. What about other centers, Kohima, Itanagar? Guys, is it clear to you? And guys, same reason for the case of oxygen and sulfur. And you have to remember that Chlorine is the element who has got the highest negative electron gain enthalpy in the whole periodic table. Okay. So I am writing the explanation. First of all, copy this question. After that, I am writing the explanation. Copy this question. Why chlorine has higher negative electron gain enthalpy? You can put negative sign as well. Okay. Copied? Okay guys, so you can copy the answer. Chlorine has higher negative electron gain enthalpy as compared to fluorine because in chlorine incoming electron suffers relatively less force of repulsion as compared to fluorine due to its smaller size. Or we can say because in fluorine incoming electron enters to n equal to 2 shell. Because in fluorine incoming electron enters to n equal to 2 shell and feel more repulsion. You can simply write this one. That would be enough. Guys, the same question will be in case of oxygen and sulfur. And you can remember that chlorine has highest negative electron gain enthalpy in whole periodic table. Copy please. After copying that, just confirm. I'm repeating this. Chlorine has higher negative electron gain enthalpy as compared to fluorine because in chlorine, incoming electron suffers relatively more force of repulsion as compared to fluorine because in fluorine, incoming electron enters to n equal to 2 shell. N equal to 2 shell, which is relatively smaller. Whereas in case of chlorine, it enters to the n equal to 3rd shell. Copied? Any confusion or doubt? Can you move on? Guys, have you copied that? Now, the same answer for oxygen and sulfur. Why sulfur has higher negative electron gain enthalpy as compared to oxygen? Okay, answer would be same. Okay, answer would be same that we have just written for the case of fluorine and chlorine. Okay, that would be same. Now, in the statement of the electron gain enthalpy, we have written over there, it is the enthalpy change or the energy change. Now, let's see. For the noble gases, guys, if I say helium is gaining one electron to form He minus, what will be electron gain enthalpy for this one? Will it be positive or negative? Electron gain enthalpy when helium gains one extra electron to form He minus. Will it be positive or negative? You have to just think whether this one is becoming more stable or less stable. My question is, if helium gains one electron to form He minus, what should be electron gain enthalpy, negative or positive? Okay. This is positive or zero. See, helium is a noble gas which is already in its most stable state. Okay. So now we are changing an element from stable state to less stable state. In that case, your electron gain enthalpy will become positive or zero. Remember one thing, in maximum cases it is negative, but not always. Okay, but not always. So you have to remember that in case of noble gases, electron gain enthalpy will be either zero or positive. Reason being, noble gases are already very stable, and after gaining the electron they will become the less stable. Okay, so ultimately what are we trying to do in case of noble gases, that there is already stable system. If we have to add the extra electron to the stable system, in that case we have to supply the energy. Guys, make it clear that if a system is already stable and you are still looking to gain one electron over there, then in that case you have to supply the energy. Okay, that's why it is in case of noble gases will be positive or zero. In the many books, or we can say many times, you will find out that the definition of the electron gain enthalpy is written as it is the energy released. Guys, remember, it is not energy released, it is the enthalpy change or energy change. Okay, because it can be positive, negative or zero, anything. Okay, please copy this, and if anyone has got any confusion regarding this one, please you can ask me. Any point of confusion or doubt? Any confusion or doubt? Okay. Now guys, I'm summarizing it and after that I'm giving you question. Now after discussion, after the whole discussion, while attempting the question, is it constant? Constant means, what is constant, Itanagar? What your exact question? Guys, now what I'm summarizing it. First of all, you have to remember, Itanagar, you can put your question again. I'm summarizing it, that first of all you have to check that if system is already stable and it can be stable by you can say the fully filled configuration, by the exactly half filled configuration, we know that those are very stable configurations, okay. If this situation is over there, in that case it might be positive or zero, okay, means least energy will be released over there. And if this situation is not true, in that case you will check out that after gaining the electron, which species is much more closer to the achieving the octet. Or if this statement is not very much clear to you, you can simply assume that the species which has the higher nuclear charge, will definitely releases the more energy. Okay, what I am trying to say, that you have to just check out if species having the fully filled configuration or half filled configuration, they are very stable configurations. So in that case, electron gain enthalpy will be either 0 or positive. After that, you can simply think about it that the species which has the higher nuclear charge will releases the higher energy. Okay, this is the whole summary of the electron gain enthalpy that we have discussed till now. I'm giving you a question. You have to answer that question. Yeah, in case of noble gases, it will be 0 or positive. Okay, this is not exactly 0, it is positive. Okay, so guys, is it clear to everybody? Anybody wants to ask me anything, any question before starting the discussing the question? Anyone wants to ask me anything? So this is the question. Arrange the following in the order of increasing electron gain enthalpy. Guys, remember, increasing electron gain enthalpy means negative. Means the species which will releases the highest energy will be put at last. Okay. First of all, tell me, is there any confusion regarding the question? Increasing electron gain enthalpy, that the species which will have the highest negative electron gain enthalpy will be put at the last with these symbols. Okay. Suppose this is A, B, C and D. This is your E. It means that in case of A, this is most negative and this is your least negative. This is the meaning of electron increasing order of electron gain enthalpy. Okay, so I'm giving you question. Copy this, and this is the question for you. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Do this. Now guys, after discussing every factor, you have to think about it very calmly and clearly. Check out the fully filled configurations, exactly half filled configurations, okay? And then do this question. You can remove lithium from here. Please remove lithium from here. After doing this, you can reply on the screen. Done? Kohima, are you there? Are you still connected to us? Shillong, Itanagar, guys, have you got the answer? Tamalong, are you still connected to us? Show the centers. Okay, B twice. I think there are some other elements as well other than beryllium, dear. Sisipur. Sisipur, are you there? Itanagar, Kohima, Sisipur, guys, are you still connected to us? Shillong, you have to write other elements as well other than beryllium. What will be the answer for this one? Guys, you can look at this. No. Little bit changes. See, this one will have the fully filled configuration. Last orbital will be fully filled. This one will have the half filled. So this is present in the two scenarios. Other than that, there is no such cases available. It means that the other remaining four elements will be compared simply that after gaining of one electron, what is the new scenario? Okay, or which one has the higher nuclear charge will have the higher electron gain enthalpy. So we can conclude that beryllium will have the least. After that, beryllium. After that, we will have nitrogen. Then we will have boron, carbon, oxygen, and fluorine. I have told you that please, everything has been discussed with you. Now be careful. See, nitrogen has extra stable half-filled configuration. That's why it will be relatively less electronegative. Or you can remember that in these two cases, it is positive. Electron gain enthalpy is positive. Okay, and in the remaining cases, you have to just check which one has the higher nuclear charge will be your answer. Guys, remember while solving the electron gain enthalpy questions, first of all, just check out, is there any species who has got the fully filled configuration or half filled configuration? If yes, they will have the less negative electron gain enthalpy. Okay, is it clear to everyone? Is it clear to everyone? If yes, then you can please do this question as well. Guys, please confirm, is it clear to everyone? Copied? Itanagar, Shillong, Kohima, Sisipur, guys, is it clear to you? Arrange these elements. Increasing order of electron gain enthalpy. Increasing order of electron gain enthalpy. Atomic numbers I am writing for you. Zinc is 30, cobalt is 27, copper is 29. Do this question and tell me the answer. Do this question and tell me the answer. Sisipur, I was talking to you for last 5 to 10 minutes, but you were not responding. Why so? Guys, do this question and please reply. You can use the electronic configurations, okay? That will give you a lot of hint. Done? Shillong, Kohima, Sisipur, Itanagar, guys, have you attempted this question? Okay, I'm waiting. Guys, let's start. See, if you write the electronic configuration for the zinc, I think I have written electronic configuration for every element. Okay. Guys, look at the electronic configuration of zinc. It will be 4s2 3d10. This one will be 4s2 3d7, and this one will be 4s1 3d10. Okay, 4s1 3d10. Now look at this. See, zinc has got the highest stable electronic configuration, so its electron gain enthalpy will be least. Its electron gain enthalpy will be least. Zinc should come at the last. Then if I talk about the copper and the cobalt, obviously, if we talk about the copper and the cobalt, then cobalt will has the relatively less stable electronic configuration. Okay, so now the question is between copper and cobalt, what should be the answer? What should be comparison answer? Which one will have the higher electron gain enthalpy, and why? We have clarified that zinc will have the least. What about copper and cobalt? Think about it very clearly, that here incoming electron will enter to the 4s1 and here in the 3d7, where it is easy to gain the electron, in 4s1 or 3d7. Guys, see, I know these questions are relatively, or we can say little bit better. Okay, so you have to think about the every question and every time. Okay, please think about it and tell me what should be the answer. Think about it. Okay, cobalt will have higher or lower as you compare to copper? Shillong, Kohima. Guys, what are you doing? Shillong, are you still there? Are you still there? What would be the answer? What do you think between cobalt and copper? No. The answer is this one. My dear student, answer is this one. Okay, let me clear this one to you. First of all, let's take a break. I think so. After the break, we can continue with this question, okay, with a fresh mind, okay. See you after the break. See you after the 5 minutes. Hi guys, back again. Confirm once. Those who are back into the classes, so we can discuss this question. Shillong, Kohima, Itanagar, Sisipur. Guys, are you back? Okay. What about you guys? Kohima, Itanagar, Sisipur. Sisipur, are you still on the break? Okay guys, so let's discuss with with this question. Guys, first of all, please do not or don't panic while look at these kind of questions. See, we are in the inorganic chemistry and there are many things that we have to learn. Okay, I'll try to explain it as I have told you in the beginning of the inorganic chemistry, that there are many things which are actually out of the order. Means they are not following the general trends. See, accordingly, zinc is placed at the correct position, no issues. Okay, but if we talk about the copper and the cobalt, the order is again something different. Like in case of fluorine and chlorine, and in case of the oxygen and the sulfur. Okay. Similarly, in case of nitrogen, nitrogen has got the least negative electron gain enthalpy if I compare with the oxygen, fluorine, and the carbon, because it has got the stable configuration. So guys, these points you have to learn. You have to remember these points. Similarly, here you can see, if I try to explain it, guys, what will happen in case of copper, as it got one electron, its outermost shell will be completely filled. That's why it will acquire the highest electron gain, highest stable configuration. That's why the nuclear charge in case of copper is relatively very, very high as I compared with the cobalt. That's why we put copper at the first position, then followed by the cobalt. Zinc, because it's already least most stable, that's why we have put zinc at the last. Okay, so this is the explanation for this one, that copper has the higher nuclear charge, that's why copper will have the higher negative electron gain enthalpy as I compared with the cobalt, and zinc is as usual will be placed at the last one. Okay, this is the explanation for this one. I hope so it is clear to everyone. If still anyone has got any query or doubt, please, you are most welcome. You can ask me. I'll clear it to you. But yeah, I'm telling you guys, there are few things that we have to learn. Okay. In the next chapter, which is chemical bonding, guys, this is that chapter gonna be the backbone of the inorganic chemistry. Okay, that will start in the next class, and that is very, very interesting. In that chapter, you won't find, or I can say that you will find out that there are least points which are not followed by the general trend. Okay, so that is quite easy to learn. What you want me to repeat, Shillong? Explanation? Are you asking for the explanation? Are you asking me? Okay. I said that copper has relatively higher nuclear charge as compared to cobalt. Therefore, its electron gain enthalpy relatively higher as compared to the cobalt. That's the reason for this one. Guys, this is just a little bit out of the trend. You have to remember this sequence. Okay? You have to remember this sequence. Any query, any question for me, guys? Can we move on? Are you done with this, guys? Can I have one responsible person on the system at every center, so he or she can reply to me? Okay. Other than that, guys, I think I have already discussed with you. You can remember this order: chlorine, fluorine, bromine and iodine. This electron gain enthalpy order. Then sulfur, oxygen, selenium, tellurium. Okay, this is the oxygen family, if you remember this. Other than that, sulfur, oxygen, phosphorus and nitrogen. Okay, these are important orders that you have to remember. Okay, then the next one, silicon, carbon, phosphorus and nitrogen. Guys, quite different order. You have to remember this one. Okay, copy this one. Copy this one. Any confusion or doubt? We have put nitrogen at the last because it has got the stable configuration, stable half-filled configuration. That's why it has got the least negative electron gain enthalpy. That's why I have put it at the last. You have to learn this order. Any query or doubt? Guys, those who are sitting in the class and just looking at me like this or like this or staring at me, please guys, if you have any confusion, you can ask me. You're most welcome. What do you want to ask me, Itanagar? What's your question? Please guys, be relaxed. Okay, here we have to learn something. Okay, I'm trying to deliver you best. Okay, in between, if something is not clear to you, you can ask me. I'm open to it. Yeah, Itanagar, please repeat. What do you want to ask me? Quick. That's all about the electron gain enthalpy over. Okay, the next term is electron affinity. Guys, first of all, in many books, or we can say, you will find out at many places, they said that electron affinity and electron gain enthalpy are exactly same. Okay, no guys, this is not true. Electron affinity and electron gain enthalpy are not same, but they are related to each other. Okay. Electron gain enthalpy says that it is the energy changes or the change in enthalpy when when an isolated gaseous atom takes up extra electron. This is the electron gain enthalpy. Whereas, or we can say, we can calculate the value of the electron gain enthalpy. Whereas electron affinity says that it is the affinity towards the electron. Ultimately, the species which can pull the electron towards itself, or we can say that the species which can attract the electron towards itself is known as what? Electron affinity. Guys, electron affinity is the qualitative property. Means that it simply tells you that which species can pull the electron towards itself more aggressively as compared to the other one. Whereas, if I talk about the electron gain enthalpy, it is a quantitative property. Means it will tell you that after gaining of electron, how much energy will be released or how much energy would be consumed. Okay. So, affinity means attraction or love. Towards the electron. Okay. Now, you can remember this one, that electron gain enthalpy or electron affinity, you will simply write it A, will be negative of electron gain enthalpy. Okay. Next point of difference, it is a quantitative property. Quantitative means, one second guys, one second. Oh, the electron affinity, it is a qualitative property, whereas this one is it is a quantitative. Means we can measure the value of electron gain enthalpy, whereas we cannot measure the value of electron affinity. Okay, we can simply compare that which species has higher tendency to pull the electron towards itself. Okay, so you can copy this one guys, and please tell me, is there any confusion or doubt regarding this one? Is there any confusion or doubt regarding this one? And guys, one more important thing, if in the question this says that what will be the order of electron affinity or electron gain enthalpy, if they are already using the word electron gain enthalpy or electron affinity, then you have to go through the question. Means in that case, if they say, if the order of electron enthalpy and the electron gain enthalpy is similar, means question is given to you. In the question, they said that what will be the order of the electron affinity. If I use this one, according to order should be reversed. According to this, order should be reversed. But in the option, reverse order is not given to you. In that case, you will proceed with the order of electron affinity. I'm taking an example. See, question is, which one of the following is true for electron affinity? Okay, options are chlorine, fluorine, bromine. B, fluorine, chlorine and bromine. C, bromine, chlorine and fluorine. And D, fluorine, bromine and then chlorine. Okay, so guys, if you look at the question, you will find out that there is no correct order for the electron affinity. According to the electron affinity concept, the order should be reversed. According to the electron affinity question, the order should be reversed. So guys, see, this is the order for the electron gain enthalpy: chlorine, fluorine and then bromine. If you say electron affinity or electron affinity, this order should be reversed, so you will find out it should look like this one. Is there any order given to you? In the question, is there any order like this given to you? No. This should be the correct order for the electron affinity. So I am saying that in the many books, they are saying that electron affinity and electron gain enthalpy are exactly same. But logically, in the higher examinations, you will find out there is a big difference between these two. Okay. So up to school level, or we can say your boards level, electron affinity and electron gain enthalpy would be same. Okay. So here, the correct option would be what? A. Ideally, this one should be given to you in the question, which is not given. So we cannot mark that option. Okay. So we will go with the order of the electron gain enthalpy. Please copy this question. and tell me, is it clear to everyone? Any confusion or doubt regarding this one? Can we move on? Hey Shillong, Itanagar, Kohima, Sisipur. Guys, is it clear to you? Yes, only A is correct. Okay, that's good. So guys, that's all about electron affinity. That's over. So guys, let's move on to the next one. The topic is electronegativity. Electronegativity. Guys, first of all, let me introduce the concept to you. Okay, after that I'll write the definition for you. See, electronegativity means tendency to pull the electron by an atom in bonded state. I'm repeating. It is a tendency to pull the electron towards itself in bonded state. Okay, that will be the electronegativity. See, if I write the definition, you can copy this definition along with me. I'll explain it with the example. Please copy this definition. The tendency of an atom in a compound to pull electrons towards itself is known as electronegativity. Okay, now I said B is more electronegative than A, and they are like this in the bonded state. I said B is more electronegative than A, and A and B are bonded like this, means that the tendency to pull the electron in AB compound is higher than the A. So what will happen? That B will pull electrons towards itself slightly. Okay, so let's say suppose after pulling the electrons comes much near to the B. We know that the species which has the electron is known as the will acquire the negative charge, and the species which do not have electron or which loses the electron has got the positive charge. I said B will pull the electron towards itself, therefore B will develop certain negative charge. Guys, this is a sign of delta. Delta means small change. Okay, and this is your delta positive. See, equal and opposite charge has been created on the species. Okay, due to the electronegativity difference. First of all, guys, tell me up to this, is it clear to everyone? Tell me quickly. Please copy this and tell me quickly that is it clear to everyone till now in case of electronegativity? Okay. Shillong, is it clear to you? Okay. So now, if I say C is more electronegative than B and B is more electronegative than A, okay, I am saying then the scenario is this one: A, B, C. So guys, what will happen? That C is more electronegative than B and then A. It means that C will pull electrons towards itself, okay, from the B. B will develop certain positive charge, okay. Now, what will happen? that B is more electronegative than A, so B will pull some charge from A, so it will develop negative charge, and A will develop what? Positive charge. Guys, please make it clear that if this scenario comes to you, and one more thing, make it delta 1 and this one is delta 2, and this is delta 2, this is your delta 1. Okay, because it is not true that the exact number of electron, or we can say the exact charge pulled by the C from the B will be true when B will pull electron from A. Okay, so I have taken the different magnitudes. Okay, that C will pull electrons towards itself, so it will develop certain negative charge which is delta 1. In according to that, B will develop certain positive charge. Similarly, B will develop certain negative charge from A, okay, and the value of that is 2. So this is the electronegativity. Now the point is, to measure the electronegativity, many scientists has attempted to explain this, like Pauling scale, Mulliken scale, okay, Alfred Roscher scale. So guys, these are the scales available to us to measure the electronegativity, out of which the best scale to explain the electronegativity was the Pauling scale. Okay, out of which the best scale to measure the electronegativity was the Pauling scale, because Pauling said that the electronegativity can be measured only when the element is in the bonded state. Okay, the element is in the bonded states. That's why we use the Pauling scale. Now, I am telling you overall electronegativity order that we have to remember, and I'll give you mnemonic as well to learn that. Now, there is your overall electronegativity order. Guys, I am writing only those elements which are very, very important to us. See, fluorine is the most electronegative element of the periodic table. Then oxygen, chlorine, bromine, iodine, sulfur, carbon, hydrogen. Guys, you can remember this one. This is your phone. You can write it. Phone. Call. Brother is coming home. So guys, these are few important elements whose electronegativity order we should remember. Okay, and you have to remember that fluorine is the most electronegative of the periodic table till now. Okay, on the Pauling scale it has value 4. On the Pauling scale it has value 4. Please copy this. Copied? Anyone wants to ask me anything till now? Shillong, Kohima, Sisipur, guys, have you copied that? Okay, so let's move on. Factors affecting electronegativity. First is atomic size. You can remember that atomic size varies inversely with the electronegativity. Means with increase in atomic size, nuclear charge will decrease, and if nuclear charge decreases, means that tendency to pull the electron will also get decreased. Okay, so we can say that with increase in atomic size, electronegativity decreases. Okay, I hope so it is clear to everyone, because with increase in size, nuclear force or nuclear charge decreases. Okay, next. Nuclear charge. It varies directly with the nuclear charge. With increase in nuclear charge, electronegativity increases. Copy this. Copy this. Other than that, you can simply remember, on moving left to right in periodic table, electronegativity generally increases, whereas on moving top to bottom, electronegativity decreases. Okay. Copy, please. Other than that, scales to measure electronegativity. I'm writing just scales because we don't need detailed explanation for that one. First is your Pauling scale. This is your most successful. Most successful. Okay, this is your most successful because it consider, guys, this point is important with respect to your examinations, because it consider electronegativity of element when it is in bonded state. Okay. The most electronegative element on the basis of Pauling scale, the most electronegative on the basis of Pauling scale was fluorine, and its value is 4.0. Guys, remember one thing, that this 4.0 has no mathematical significance. Means this is not calculated on the basis of any calculations, okay, any mathematical derivation. It is an arbitrary value, means it is an assumed value. It is an assumed value. Okay, and the value of other elements, for example, for oxygen it is 3.5. If we say about oxygen, it is 3.5. Okay. So guys, this 3.5 is actually calculated in reference to the fluorine. Now, the value of other elements which has been calculated in the Pauling scale was on the basis of comparison with respect to the fluorine. Okay. They are not calculated mathematically. They are just compared values. Okay. You have to remember this one. Sometimes it is asked in your examination, what is the meaning of 4.0 on Pauling scale? How do we get this value? So guys, you have to remember this is not calculated. This is an assumed value. Okay. Then the next scale is your Mulliken scale. You have to just remember this name. Again, no significance for this one. Then Allred-Rochow. Even this is not in the part of the syllabus, so you can leave this one. Okay, so these are the scales on the basis of which we have calculated the electron negativities. Now the question is, one more important question for the examinations is electron affinity and electron negativity are same? Guys, again, this is the important question for your examinations. Can anyone please tell me whether it is, are they same or not? Can anyone please tell me, is electronegativity and electrogain enthalpy are same, or electron affinity are same? Exactly, they are not same. Good. Answer is no. Okay. Remember guys, electron affinity is tendency to pull the electron. Electron affinity is tendency to attract the electron when element is in isolated gaseous state. Whereas electron negativity is the tendency to pull the electron when element is in bonded state. Okay. For electron affinity, elements should not be in the bonded state. For electron gain enthalpy, elements should not be in the bonded state, whereas in case of electron negativity, elements should be in the bonded state. Is it clear to everyone? Do I need to write it again? Guys, you want me to draw a reference table for this one? Remember, this question will be definitely asked in your examination. The chances to ask this question is about 95%. Okay. Almost when you have 3 examinations in the whole year, in the one examination you will definitely find this question. Guys, do I need to differentiate between these two? Do I need to draw the difference table, or you can do it on your own? Okay. Thank you. Okay. Electron affinity, electronegativity. Please, you can copy with me quickly. Tendency. Guys, please copy with me. I have already explained it to you. Okay. You can copy along with me. Tendency of an atom of an isolated gaseous atom to gain the electron. To gain the electron. And during the process, the energy released is known as electron affinity. This is your tendency to pull the electron by an atom to pull the bonded electron. You can write the bonded electron by an atom when it is in bonded state. Copy this quickly. Second, you can write it has unit kilojoule per mole. It has no unit. No unit. This is the difference. Two differences are significant. You can write this one. Copied. Isolated means it is not in the bonded state. It is free atom. It is free atom. No influence of other atom. Guys, I'll share a sheet with you based on the questions of the electron gain enthalpy and the ionization enthalpy. If it is not done by tonight, by the 9 or 10, please remind me once on the group so that I'll share the sheet with you. Okay. Questions will be MCQs. Okay. Questions will be MCQs. You have to practice those questions. And we are left with one more concept in this one. After that, this chapter will be over. And that will hardly take 15 to 20 minutes. After that, we will start with the chemical bonding in the next class. Anyone wants to ask me anything in today's session? Yeah, please, you're most welcome. Wow, Itanagar. Itanagar, this is periodic table. How do fishes get high? How? How Shillong? Wow. Okay. You can put this joke meanwhile during the class. Okay. So guys, nice attempt, dear. Most welcome. So guys, I hope so everything is clear to you in today's session. So see you in the next class. Till then, guys, take care. Bye bye. Please take care of yourself. Stay healthy. See you next time. Good night. If you have any query, you can please post your doubts in the WhatsApp group, or you can ask me in the next class.